In previous video, I have shown you how to design a Turing machine for the input symbols 0 raised to n, 1 raised to n. And in this video, I will show you what is PDA. PDA is a pushdown automata where it uses a stack to store its input symbols. Initially, the top of the stack of PDA is Z0 and it stores the input symbols, and as you know the stack has its property as it is last in first out, so it will store like that way. We will see one example how the pushdown automata works. Suppose our language is balance parenthesis. Now what is balance parenthesis? Balance parenthesis is the pair of balance matlab equal number of pairs that should be balanced, that are valid strings, like that, this way, this way, this way, and this way. Okay, these are balances, and invalid strings are invalid strings which will not be accepted by the PDA. So we will design the PDA for the balance parenthesis. Balance parenthesis will initially be in Q0. We will get our input. We are taking a language which accepts this symbol. Okay, so initially we get this open parenthesis, and we have to write the top of the stack and what we are pushing and top of the stack. Okay, so here we have completed this. Now we get a close parenthesis, so our stack will be now filled with opening parenthesis. Now we got our next input symbol as close parenthesis, so it should enter into a next state Q1 with close parenthesis, and our top of the stack is opening parenthesis, and it should be popped out. The popped out signal is shown with the help of epsilon. Okay, now our next input symbol is again a open parenthesis, so it should enter into a Q0 again, see, with top of the stack, and this. Here is the, now this got cancelled again, there comes here will get cancelled. So this way PDA will work. It will again found the next input symbol close parenthesis, it will go here, it will pop out the close parenthesis and will enter into the next state Q2, where our input symbol will be epsilon and top of the stack will be Z0, and we will do nothing and we will just print the top of the stack Z0. If our input symbols will be, so this is the PDA for the balance parenthesis for the length of for the input string this. Suppose our input string was this double opening parenthesis then close parenthesis, and this is also a valid string. So how it will work here, first this input single here top of the stack Z0, and we will get our stack Z0 and this. Now we again found our next input symbol as opening parenthesis, so it will push into the stack. So we have not written the statement for this, so our input symbol is this, and our top of the stack is this, opening parenthesis. So what will we do? We will simply push it, and our top of the stack will remain this only. Okay. Now we have done for these two. Now we get a close parenthesis. Okay, we have done this. Now we again got a close parenthesis. Therefore, here will also come a loop which will simply pop out the close parenthesis. Hence, we will enter into the final state Q2. So thus this works. Now we will take one another example for PDA, which accepts strings 0 raised to n, 1 raised to n, such that n is greater than or equal to 1. So it will use the same logic. We will be initially in Q0, and our string is 0 0 1 1. Okay, Q0, we will found first input symbol 0, and our top of the stack is Z0. We will simply push it onto the stack, which is Z0. Now we again got our next input symbol as 0, so it will be in the same loop 0, and upon top of the stack is what is Z0. Now our top of the stack is 0, so we have write 0, and we will simply push it onto the stack, and now our top of the stack will be 0. Okay, now we enter into Q1. Why? We have got 1, so we will be into the next state 1. We enter, and our top of the stack is 0, so we have to simply pop out. Again we found 1, so we will do the same thing, and now we will enter into the state Q2, which is the final state. Here if the input symbols will be 0 1 0, sorry, 0 0 1 1 0 1 0 0 0 0 0 0 1 1 1. So how it will work for this is, we will initially be having a top of the stack as Z0, and our first input symbol is 0, so we will enter into Q0, and our top of the stack will be 0. Now we again entered Q0, 0, so 0, and our top of the stack is 0. We will push it onto the stack. We again counted 0, so this. Now we found our first one. We found our first one, so we will pop it out. Epsilon means popping. Again we found 1. We will pop out. Again we found 1. We found out. And now if our how it will enter into Q2, that we found epsilon, no input symbols. Our top of the stack is Z0. We will simply print top of the stack Z0. So our top of the stack is Z0, hence it will be get accepted. So in next video I will show you some other concepts of TCS.